Some functions are odd, some are even, and some are neither. How do you tell? I'll show you right now. Welcome to Math Bytes. I'm Allison, and today we're talking about odd and even functions and symmetry. So here are your definitions. The function f is an even function if f of negative x is equal to f of x for all x in the domain of f. And the function f is an odd function if f of negative x is equal to negative f of x for all x in the domain of f. Okay, let's do an example and make some sense out of those definitions. So I have a function here, f of x is equal to 2x to the fifth plus 7x. So let's determine if this function is odd, even, or neither. So I'll replace x with negative x. F of negative x is equal to 2 times negative x raised to the fifth plus 7 times negative x. Now, since I'm raising that negative x to an odd power, that means I'm going to keep that minus sign. So I get negative 2x to the fifth minus 7x. And I can take that minus sign out front, and I get negative quantity 2x to the fifth plus 7x. So in this case, f of negative x is equal to negative f of x. That means that this function is odd. Okay, let's keep going. I have a function here, g of x is equal to x squared. So again, let's replace x with negative x and see what happens. G of negative x is equal to negative x, quantity squared. And because I'm raising to an even power, that negative sign goes away. So that's just equal to x squared. So in this case, g of negative x is equal to g of x. That means that this function is even. Okay, I have one more for you. H of x is equal to 3x cubed plus x squared. So let's replace x with negative x and see what happens. H of negative x is equal to 3 times negative x cubed plus negative x squared. And simplifying, I get negative 3x cubed plus x squared. Now you'll notice in this case that h of negative x is not equal to h of x. And h of negative x is not equal to negative h of x. So this function is not odd or even. It's neither. The graph of an equation is symmetric with respect to the origin if replacing x with negative x and y with negative y leaves the equation unaltered. So let's take a look here. I have an equation xy equals 5. Let's replace x with negative x and y with negative y. We get negative x times negative y equals 5, and that's the same as xy equals 5. So it has not altered my equation. So this graph is symmetric with respect to the origin. Okay, how about this one? Y equals x cubed plus 1. Same thing, let's replace x with negative x and y with negative y. We get negative y equals quantity negative x cubed plus 1. And rewriting, that gives me negative y equals negative x cubed plus 1, or y equals x cubed minus 1. Now this has altered my equation. So this graph does not have symmetry with respect to the origin. Okay, I have one more thing to tell you about odd and even functions. The graph of an even function has symmetry with respect to the y-axis, so something like this. And the graph of an odd function has symmetry with respect to the origin, so something like this. Remember, there are a couple of ways to determine whether a function is odd, even, or neither. You can look at its equation, replace x with negative x, and see what happens. Or you can graph it and see if it has symmetry about the y-axis, the origin, or not. That's it for this episode of Math Bytes. If you like our videos, please subscribe to our channel. And if there's something you'd like to ask us, just send us an email. We're at contactmathbytes@gmail.com, and we'll see you next time.